Hello dear friends, welcome to Humble Mark Academy. In this video guys, we shall be looking at the correction of the Faculty of Engineering and Technology, that is the FET that was written in Buea. Friends, the 2023 session guys, we shall be looking at it from question 20 to question 80 guys. We shall be looking at it throughout this video, so stay tuned and watch the entire video so that you're going to understand every bit of the concept involved. So guys, I'm super sorry that the solution to this question is coming so late. Just that I had some I had some difficulty that prevented me from making the solution as early as possible for students to understand. I know that some of you will be writing these exams tomorrow. Good luck to you, but please watch this video before you enter into the hall. So guys, without further waste of time, friends, if you're new to this channel, don't forget to hit that subscribe button looking at you, because it is going to encourage me a lot to keep on creating more content for you. Thank you very much guys, and like the video, it motivates me. Let's get started friends. The question 20 friends, as you can have on screen, it simply reads that a rescue helicopter lifts 50-kilogram rock climber by a rope from a cliff face. The rock climber is accelerated vertically at 5 meters per second squared. What is the tension in the cable? Okay, so guys, if the if the climber eventually lifts it vertically upward, it therefore means that the tension force in this case has to be greater than the weight of the object. It therefore means we are going to have our T minus mg equal to the mass times the acceleration. Keep in mind that our goal is to get the tension force acting. The question gave us the acceleration of the climber, of the rock climber already. So if we substitute and make T the subject, we are going to have T to be the same like a plus g, all that multiplying m, since m is common. If we plug in our values, we're going to have T to be the same like our a is 5. Our gravitational fusion guys throughout this concours, it is going to be 10 meters per second squared. If we add it, we are going to have 15 times 50 gives us an answer to be 750 newtons. So guys, option C is the best option for this question. All right, question 21 friends reads that which of the following describes a situation requiring no net force? Okay, option A is saying that a car starts from rest and reaches a speed of 80 kilometers per hour after 15 seconds. Guys, this is acceleration since the speed started from some value which is another in a given time interval, so it is acceleration. Then option B, a bucket is lowered from a rooftop at a constant speed of 2 meters per second. Guys, this is what has no acceleration since the bucket is lowered at constant speed. Keep in mind that it is not a true statement that each time the speed of an object is constant, the object is not accelerating. If you take a case where for an object moves around a circular path at constant speed, that object accelerates at the rate equal to the centripetal acceleration. But in this case, the bucket neither is wheeled around any circle, right? So it does not accelerate. So option B, guys, even without looking at the rest, has to be the best option. But let's look at the rest. Option C is saying that a skater glides along the ice, gradually slowing down from the speed of 10 meters per second to a speed of 5. Guys, this is deceleration or retardation. In other words, guys, negative acceleration. Okay, this is that the pendulum of a clock moves back and forth at constant frequency of 0.5 cycles per second. There is some angular velocity involved. There's some angular acceleration involved here, so it's not the best. So guys, let's look at question 22. It reads that a child pushes a block across the floor with a constant force of 5 newtons. The block moves with a constant force of 5 newtons. The block moves in a straight line and its speed increases from 0.2 meters per second to 0.6 meters per second. Okay, now which of the following must be true? Okay, A, the force applied by the child is greater than the force of kinetic friction between the block and the floor. Guys, option A is the best option even without looking at the rest. This is so because if the force applied by the child is not big enough than the friction force, guys, the child will be unable to push the block. Okay, the child will be unable. But if the friction force is more than the driving force of the child will be unable to push it. But if the child has to push that block such that it accelerates, then the driving force of the child must be greater than the friction force. Option B is that the force applied by the child is less than the force of of kinetic friction. Wrong, guys, wrong. Option C is that the force applied by the child is greater than the force due to the weight. The weight has nothing to do with the driving force of the child. The weight of the object, friends, does not indirectly influences the driving force of the child. D is saying that the force applied by the child is less than the force due to the weight. It is not dependent. Great. So guys, option A is the best option. Let's go to the next, friends. Let's go. Question 23 is saying that a carpenter who is having a difficult time loosening a screw puts away his screwdriver and loosens and chooses another with a handle with a larger diameter. He does this because A, increases force, increases torque. Okay, so guys, let's have a general scenario of the problem. Let's recall that the torque is simply given as the force times the lever arm distance. So in this case, guys, we can see that, friends, the answer has to be option C, right? Option C, because option C is saying that increasing lever arm increases the torque, guys, because the one that has a much greater diameter simply is the lever arm distance that they are talking about here. Option A is saying that increases the force, increases the torque. The person has in simply used the one that has a much larger diameter. The force has been kept constant. Meanwhile, the lever arm distance, which represents the increment in the diameter, has been increased. So the force has nothing to do in this case. B, decreasing the force decreases the torque. The guy has not, or the carpenter, friends, has not decreased the force. The force is kept constant. C, increasing the lever arm distance increase the torque. Perfect, guys. Option D, decreasing the lever arm distance decreasing the torque. The guy would rather increase the lever arm distance. Great. So option C is the best. Question 24, friends, is saying that a person pushes on a door and it swings open. Where should the force be applied in order to make the door swing open as quickly as possible? Option A. So friends, this question is simply from concept which is known as the turning effect of a force. It simply tries to discuss those factors that will affect the turning effect of a force, and the distance from where the hand is being applied has a much greater influence as to the turning effect of that force. The further the distance from the hinge, the more easy it is to actually push the door for it to open. Option A is saying that on the edge of the door nearest to the hinge. Wrong, guys, wrong. Option B, at the center of the door. Wrong. Option C, on the edge furthest from the hinge, guys. This is the best option. Okay, it's the best because if your hand is being applied at some distance furthest from the hinge, keep in mind that the hinge is simply that point at which the door actually rotates. It's the fixed point of the door that actually rotates. Then option D is that it falls anywhere on the door. Wrong, guys. So option C has to be the best option for this question. Okay. Question 25 is saying that a 1 meter board with uniform density hangs in static equilibrium from a rope with tension 7 newtons. A weight hangs from the left end of the board as shown. What is the mass of the board? Okay. So guys, they want us to get the mass of this board. Looking at this scenario, guys, it shows that we must have to use the principle of moments, right? But since the equation towards that this our board this our metal board has a uniform density, therefore means that the mass of the board or the weight of the board has to be concentrated at some point at the center of the board, which is called the centroid of that board. Means it has to have a magnitude mg, where m is the mass of the board, g is the gravitational field strength. Now, guys, since the weight partitions the board into two equals, therefore means that this distance indicated here, guys, has to be 0.5 meters. Since the question told us that it has a length of 1 meters, means here has to be 0.5. And if here is 0.2, means here must be what, guys? 0.3. So that there some gives us 0.5. Adding with this gives us 1 meter. Okay. Now, guys, at this point now, we are ready to take moments. So if we take moments about the support, that is where we have this triangular support. Therefore means that if the system has to be in equilibrium, guys, it therefore means that the sum of anti-clockwise moment has to amount to what, guys? The sum of the clockwise moment. Sum of the clockwise moment, guys, the weight of these 3 kilograms is simply 3 kilograms times the gravitational field strength of the earth, which is 10 meters per second squared. So we are going to have 3 times 10 multiplied by the distance from the pivot, which is simply at this support. We are going to have 0.2 meters times 0.2 times the weight, which is 3 times 10, has to give us mg. The g is 10. The distance from the pivot is 0.3. Keep in mind that this 3 kilogram force is going to cause an anti-clockwise rotation, wherefore the weight causes a clockwise rotation, so they should be balanced. Solving for m, guys, gives us our answer to be the same like 2 kilograms. So option B is the best option for this question. All right, let's go to the next, friends. Let's go. Question 26 reads that if all the forces below have equal magnitude, which one creates the most torque? Okay, guys, let's simply record that the torque is simply given as the distance from the fulcrum times the force applied times the sine of the angle between the force and the displacement from the fulcrum. This is how it is given us. We can clearly see that, guys, the torque in this case is directly proportional to the fulcrum and also directly proportional toward the sine of the angle theta. Keep in mind that I didn't say the torque is proportional to the angle theta, but to the sine of the angle theta. So now, friends, if you look at option D, the angle between this our force and the perpendicular distance from the fulcrum, guys, is more than 90 degrees, right? More than 90 degrees. So, guys, it will rather bring about a negative torque on this system. So option D is not correct. Option C, the force is acting at the center, right, at the fulcrum at some angle, so it will not give us a much larger torque. Keep in mind that the distance from the fulcrum matters a lot. Option C is not good. Then let's look at option B first. Option B, the force is being applied at the end grade, but the angle to which it is being applied, friends, it will rather make the value of sine theta to be very, very small. Keep in mind that sine theta, friends, as you all know, it lies between what? It lies between -1 and 1. Great. So option B is not good. Option A, guys, it is applied at the end, right? Perfect. And the angle with which the force makes with the distance from the fulcrum, guys, is almost 90 degrees. And sine theta is maximum when the angle theta is 90 degrees. So, guys, option A is the best option for this question. The best, friends, the best. Okay, question 27, guys, simply reads that a large rock is tied to a rubber band and dropped straight down. As the rock falls, the rubber band gradually stretches, eventually bringing the rock to a stop. Which of the following energy transfer is taking place in this process? A, kinetic to gravitational potential, and the rest. Alright, so guys, let's simply analyze that. Generally, initially, the rock, friends, has gravitational potential energy. When it is being lowered, friends, it has kinetic energy. When it eventually reaches and stretches out, it has what? Elastic potential energy. So option A is in that kinetic. The first energy we should see has to be potential, right? Specifically what? Gravitational potential. So option A and B have kinetic as the first, which is wrong. The answer is either option C or D. Let's find out. Option C is in the gravitational potential to elastic. Wrong, guys. It should leave from gravitational potential to kinetic. Option D, gravitational potential to kinetic to elastic. Great. So, guys, option D is the best option for this question. Okay, let's go on, friends. Question 28 reads that object A and B are placed on a spring as shown. Object A has twice as much mass as object B. If the spring is depressed and released, propelling the objects into air, object A will... Okay, these are the various options. So, guys, let's analyze this question very, very keenly because it's very, very easy to make mistakes and errors with this particular question. So, guys, let's analyze it so keenly. Okay, now, friends, we know for sure that when the spring is compressed and then released, it converts all its potential energy, all the potential energy stored in the spring, into kinetic energy for these two objects, right? Great. So it converts all its potential energy to kinetic energy, and the potential energy of a spring is simply given as Pe equal to 1/2 kx squared, where k is the spring constant of the spring and x is the extension to which the spring is extended up to. So, guys, we notice that the potential energy of the spring now is converted into kinetic energy for both these for both block A and block B. It therefore means that our 1 half kx squared has to be equal to 1 half mb vb squared. That is the kinetic energy for B, then which is equal to 1 half. Keep in mind that the question towards our that the mass of A is twice that of B, right? So in place of MA, we are going to have 2 MB VA squared. If we keep in mind that the 1 half, they can cancel on both sides. If you divide all through by the mass MB, we are going to have kx squared over MB equal to VB squared equal to 2VA squared. If we now divide all through by 2 and take the square root on the left hand side, we are going to have our VA to be the same like VB over the square root of 2. Great. It therefore means that, friends, the kinetic energy of block A now simply becomes 1 half the mass of A is 2, the mass of 2 times the mass of B, which is going to be 1 half into 2 MB. Then the velocity of A is VB over root 2 squared, right, which is equal to 2 MB 2 MBGH, which is equal to what, guys? The potential energy at which the blocks are going to attain. Keep in mind that when the spring is being depressed and released, the blocks are going to rise to some height, and the potential energy of those blocks initially has to be equal to what the mechanical energy of these blocks initially has to be equal to what the mechanical energy of the blocks final. So we are going to have the potential energy when they both attain some maximum height, which you can call that h, small h. So guys, if we simplify this correctly, we are going to have our HA to be the same like VB squared over 4G. Okay. Similarly, guys, similarly, friends, if we get the kinetic energy of B, we are going to have 1 half MB VB squared, which has to be equal to the potential energy when it attains that its own height. We are going to have 1 half MB VB squared equal to MB G HB. If we make our HB the subject in this case, we're going to have HB to be the same like VB squared over 2G. Okay, now guys, this our HA, we can express it as HA, which is equal to 1 half VB squared all over 2G, right? Because 2 can multiply 2 gives us 4. But friends, what is VB squared over 2G? It is what? HB, right? So we are going to have HA to be the same like 1 half HB. So option A is saying that rise or 1 foot as high as B. Wrong. Rise half as the height of object B. Great. So guys, option B is the best option, guys. Is the best option for this question. All right. So guys, let's go to the next question. The next question reads that, question 29, it reads that a 100 Newton force is applied as shown to a 10 kg object for 2 seconds. If the object is initially at rest, what is the final velocity? Okay, now guys, all we have to start by doing is by resolving this our force. Keep in mind that it acts at some angle to the horizontal, so we have to resolve it. If you resolve the force, guys, if you resolve it horizontally, because the force, the component of the force that makes the object to accelerate is the horizontal component and not the vertical component. If you resolve vertically, guys, we are definitely going to have 100 newtons cos of the angle theta, because the horizontal direction is adjacent to the right angle triangle created here. So we are going to have f to be same like 100 cos theta. So in this slide now, friends, therefore means that if you simplify, you're going to have our F to be say like 86.6 newtons. From the formula F equal to ma, that is newtons for Newton's second law for a body of constant mass. If you make A the subject, guys, we're going to have A to be the same like 100 cos 30 over the mass, which is 10 kilograms. So our A now, for instance, ought to be 8.66 meters per second squared. Quick. Now that we have the acceleration, guys, we can now go ahead now to calculate the distance covered by this object in that time interval. So we are going to use the formula S equal to ut plus 1 half gt squared. Keep in mind that it started from rest, right? It therefore means that our u in this case is 0. So if we plug in everything, we are going to have our S to be the same like 1 half. Our A in this case, guys, is what is 8.66, right? But its approximate value, in fact, its exact value is 5 root 3. Then our t squared, our t is 2 seconds, squaring that gives us 4. If we simplify for that, guys, we're going to have our s to be the same like 17.32 meters. Okay, now that we have we have our the distance covered, guys. We can therefore proceed now to use the work energy theorem, which simply states that the change in kinetic energy, guys, has to be equal to the work done by the net external force. So we have 1 half mv squared equals the work done by the net external force, guys, is simply Fs. In this case, guys, if we make our V the subject and plugging in our values, we're going to have V to be same like the square root of 2 times 86.6 times 17.32, all that over 10. Simplifying it, guys, gives us our V to be the same like 17.32 meters per second squared. Great. So, guys, option C is the closest answer, right? Wait, option C has to be the best answer for this question. Wait, okay. Let's look at question 30, guys. Let's look at it. It simply reads that if 1 kilogram block were stacked one upon the other, starting at the surface of the earth and continuing forever into space, the blocks near the bottom of the stack would have a less gravitational potential energy than the block at the middle or the block near at the top of the stack. So, guys, even without analyzing the others, option A has to be the best. Okay, it has to be the best option. So, guys, the best reason you can account for is that as it is being stocked first, it it has a very small height compared to all the others, right? Because they are being stocked from the earth's surface up till some maximum height, right? So keep in mind that gravitational potential energy, guys, depends on what? It depends on the height to which that object is. the the block at the lowest height has the less gravitational potential energy. So, guys, option A has to be the best. Option B is in that less gravitational potential energy, which is wrong. Option C is in that the same, which is wrong. More gravitational potential energy than the blocks at the middle, which is wrong, guys. So, option A, friends, has to be the best option for this question. Okay, let's go to the next, friends. Question 31 is saying that energy consumption in the home is generally measured in units of kilowatt hours. A kilowatt hour is equal to, okay, so, guys, kilowatt hours, which can abbreviate it as kh. The the prefix kilo means what, guys? Means 10 raised to the power 3. Then an hour is equivalent to what, guys? 60 minutes times 60 seconds. So if we multiply them out, we are going to have an answer of 3,600,000. So option C is the best option for this question. Okay. Question 32, guys, is saying that a winch is used to lift heavy objects to the top of a building under construction. A winch with a power of 50 kilowatts was replaced with a new winch with a power of 100 kilowatts. Which of the following statement is true about the new is which of this following statement is about the new winch is not true? Okay, so, guys, for us to tackle this problem so well, all we have to do, friends, is simply to recall solemnly that the work done W is simply given as what, guys? The power times the time, right? We have the power already, we have the time. Okay, now, guys, we can observe that the power in this that the work done in this case is directly proportional to what the power, right? It therefore means that the more uh the more power involved, the more work is going to be done. And this our W is simply given as what, guys? Power times the time. That therefore implies make our T the subject, our T becomes W over P. That's the initial time taken is going to be, we are going to use the initial power. Keep in mind that the power in this case is in kilowatt. Okay, it therefore means that this is the time it takes to do a work of which a power of 50 kilowatt is being used. Okay, what will happen now when the power now increases from 50 to 100? What will happen now? Our T1 becomes what? W over 100, right? We can write this as T1 equal to 1 half into W over 50. Great. Okay, now, friends, we know for sure that what our power is also the same like what, guys? The force times the velocity. As such, guys, the force in this case is given as what, guys? The mass is simply the weight of the object, which is simply given as what, guys? Mg. It therefore means that, friends, our M in this case becomes our P over GV. So, guys, this is the mass that is this is simply the initial mass. Now, what will happen now, friends? What will happen now, friends, if the power is doubled? Because the power virtually has changed from 50 to 100, right? It means they have doubled it. Therefore means our new mass m1 now becomes what? 2p over gv. Great. So it requires twice the amount of mass. Okay. Let's look at the options, guys. Option A is saying that the new winch can do twice as much work in the same time as the old winch. Wrong, guys. It can do, it cannot take the same time interval, okay, because we just saw that the time interval is what, guys, is a half of the initial, right? So it's going to be half of w over 50, which is the initial time. So option A cannot be good. Option B is saying that the new winch takes twice as much time to do the work as the old winch. Wrong, guys. It takes half the time. Okay, half the time. Okay. Option C is saying that the new winch can raise object with twice as much mass as the old winch. Not true, friends. Okay, not necessarily true. Then option D is saying that the new winch can raise objects mass same mass at twice the speed as the old winch. Wait. So guys, option C and option D look look pretty confusing, right? So guys, just let me know in the comment section down below which of the options you think is the best. Either option C or option D, because option C is saying that the new winch can raise object with twice as much mass at the same speed as the old one, of which the mass, as you can see, is twice this initial mass, right? But the speed in this case, if you decide to make the speed the subject of this formula, you see that it can do it at twice the speed, right? Great. So guys, uh maybe option C has to be the best, but just let me know in the comment section down below which of them you think is the best. Okay, let's look at question 33, friends. It simply reads that a spring powered dart gun fires a dart 1 meters vertically into the air. In order for the dart to go 4 meters, the spring would have to be depressed. Okay, these are the best options. So guys, let's recall that the kinetic energy stored in that spring is simply given as 1 half kx squared, where k is the spring constant of that spring. You notice that each time when the spring is being compressed and releases it, which goes to that height, guys, all its potential energy, guys, is being transmitted into kinetic energy. And as such, guys, you notice that the potential energy in this case, guys, is simply proportional to what? X squared, right? So if in order for it in order for us to have a 4, right, therefore means that what? X has to be 2, right? Great. So guys, option A has to be the best. We have to this if in order for the dart to go 4 meters, guys, the spring has to be depressed 2 times. 2 times, guys. So option A is the best option. All right. Let's go to question 34, guys. Let's go. Question 34 reads that a rock with a mass of 7.2 times 10 raised to the power 4 kilograms starts from rest in outer space and fires its thruster until it is moving with a velocity of 100 meters per second. What was the average force on the rocket due to the thruster? Okay, so guys, let's be very careful with this question. Let's be very careful. So now, guys, let's simply recall that the force on the thruster is simply given by Newton's second law for a body of constant mass, which says that F is equal to ma, making our F here is the subject already. We know that A is given as what, guys? dv by dt, right? That's delta v by delta t. And friends, you know that the time interval for which the force is acting has not been given, of which we need the time interval in order to get the force. Also, guys, consequently, we cannot get the acceleration of the rocket, and as such, guys, and hence we cannot get the average force. Okay, so in that, friends, option A, B, and C are wrong. Option D has to be the only answer because the information given is limited. Okay, we need to get the time interval in which the force is acting. So guys, option D is the best option for this question. Question 35 reads that uh, ball A moving at 12 meters per second collides elastically with ball B as shown. If both balls have the same mass, what is the final velocity of ball A? So guys, if your time is against you, guys, if I were you, I'll just hurriedly uh, click on my option D, okay? Because I've been told that the collision is elastic. elastic, guys, means the final velocity of ball A has to be equal to the initial velocity, which is 12 meters per second. But let's try to show this. Let's try to resolve the velocity of ball A horizontally. We are going to have 12 sine 60, which is 6 root 3. Resolving it vertically, guys, we are going to have 12 cos 60, which is 6. Now, guys, the velocity of V after collision, since they both have the same mass, is ever going to be V equal to the square root of the sum of squares of these components, which are going to have this. We simplify, guys, we are going to have an answer of 12 meters per second. Great. So, guys, option D is the best option for this question. All right, let's go to question 40, guys. Let's go. Question 36, guys, simply reads that, oh, question 36, friends, not question 40. Question 36, guys, simply reads that a block of mass m1 slides across a frictionless surface with speed v1 and collides with a stationary block of mass m1. The blocks together after the collision and move away with a speed of v2. Which of the following statements is or are true about the block? Okay, so guys, let's keep in mind that since we've been told that the block, since the question earlier, oops, guys, maybe there's a typing error here, guys. What has to be stationary here has to be m2. Okay, it has to be m2, guys, not m1. Please make the correction. Okay, m2 is the block that is stationary, not m1. Okay, so just make the correction, guys. Okay, so guys, if m2 is stationary, it therefore means that it has no momentum initially, and obviously, guys, has no kinetic energy. So if we apply conservation of momentum, we are therefore going to have just our m1 v1 equal to, since we've been told that the two blocks stick together and move off, right, we are going to have m1 plus m2 times their common velocity v2. So option A, the first option is good. Then now, guys, if we observe so well about their kinetic energies, we are going to have that 1/2 mv squared has to be equal to what, guys? 1/2 into m1 plus m2 into v2 squared. Great. So now, friends, this is for a case where for the collisions are elastic, but since collisions between objects that stick together after collision, collision between objects that stick together and move off with some common velocity, guys, are not always elastic. So in this case, guys, this our condition, guys, has to be true since the two objects now stick together and move off with a common velocity. Great. So, guys, option C has to be the best. Then, friends, question 37 reads that a trapeze artist who accidentally falls builds up a great deal of momentum before he is brought safely to rest by a safety net. The safety net serves A, increasing the force of the collision by decreasing the collision time. Wrong, guys. Wrong. Option B, decrease the force of collision by decreasing the collision time. Wrong, guys. The net does not decrease the collision time, but it rather increases the collision time. Okay. Option C is saying that increase the force of the collision by increasing the collision time. Great. So the first part, increasing the force, guys, is wrong, but increasing the collision time, guys, is correct. So option C is not correct. Option D, friends, is saying that decrease the force of the collision by increasing the collision time. Great, that is true. This is in accordance, guys, to the impulse theorem, which simply says that our impulse, which has a symbol letter J, is given as F times T. We have arrows on them since they are all vector quantities. Great. So, guys, in this case now, we can see that the impulse in this case is the force produced is inversely proportional to what the time, right? Great. So increasing the force simply decreases, increasing the time interval simply decreases the force exerted. So option D is the best option for this question. Great. Okay, let's go on, friends. Let's go on. Question 38 reads that the chemical potential energy in gasoline is converted to kinetic energy in car. If a car accelerates from 0 to 60 kilometers per hour compared to the energy necessary to increase the velocity of the car from 0 to 30 kilometers per hour. The energy necessary to increase the velocity of the car from 30 to 60 is okay. So guys, let's be very keen with this question. Let's start by getting the kinetic energy necessary to increase the speed of the car from 0 kilometers per hour to 30 kilometers per hour. Keep in mind that we are going to convert all these kilometers per hour to meters per second. So our kinetic energy now, which is necessary to convert it from 0 to 60, has given us 1/2 m. The velocity in this case, guys, we are going to start from with that necessary to bring it from 0 to 60 as 60 times 10 raised to the power 3, all that squared over 6 times 60, which simplifying, guys, gives us our answer to be 450 uh, meters, 450 m. We assume in this case that the mass is constant. So the kinetic energy that is necessary now to take it now a speed a speed of from 0 to 30 is now going to be 1/2 m. The velocity, friends, is 30, so we have to convert now from kilometers per hour to meters per second. So simplifying, guys, we are going to have an answer of 1800. We can call that E2. Okay, now the guys, the energy that is necessary to increase the velocity of the car now from 30 to 60 now has to be given as the difference between E1 and E2. Okay, difference between E that is E2 and E1, friends. Sorry, not E1 minus E2, because it will give us a negative answer. Okay, it has to be E2 minus E1. So if we do that, we are going to take 1800 m minus 450 m, which is going to give us an answer of 1350 m, which in this case, guys, if you observe where it is 3 times E1. Okay, 3 E1. So the right answer here, guys, has to be 3 times as great. Okay, so option D is the best option. Question 39 reads that a girl riding her bicycle up a steep hill decides to save energy by zigzagging rather than riding straight up. Ignoring friction, her strategy will A. Require the same amount of energy but less force on the pedal. That's great, guys. This is virtually the best option because the amount of energy that the girl needs in order to ride that same distance is going to be the same, but the girl needs less force in order to pedal her bicycle. So even without looking at the others, guys, option A has to be the best. But let's have it that when the girl zigzags, guys, up the hill, she is going to effectively increase the distance traveled, and as such, guys, the force required on the pedal, guys, is going to be reduced since she's going to spread the force now over a longer distance. That is the effort applied over a longer distance. So option B is in that it requires the same amount of energy and the same amount of force. Wrong, guys, wrong. Option C requires less energy and less force. No. Requires less energy and more force. No, guys. So option A has to be the best option for our question. Okay, let's go on, friends. Let's go. Question 40 reads that a wheelchair access ramp is to be designed so that 1000 Newton can be lifted to a height of 1 meter through the application of a 50 Newton force. The length of the ramp must be at least, okay, these are the best options. So guys, let's simply recall for sure that we need to start by getting the mechanical advantage produced, and as well, guys, we have to use the concept of mechanical advantage now, linking it when it's been applied on a ramp. The mechanical advantage, guys, is simply given as load over effort. As you all know, the load is 1000 newtons and the effort is 50. To simplify, guys, we have mechanical advantage to be 20. It's a unitless variable. Okay, it's unitless. Now, guys, for an inclined, the mechanical advantage can be expressed by simply taking the ratio of its length to the height. It therefore means that the length in this case, guys, has to be given as, since the height has been given as 1 meter, the length is just equal to, guys, 20 meters. Great. So option C has to be the best option. Great. Okay. Now, guys, question 41 is saying that An inventor designs a machine that he claims will lift a 30-kilogram object with the application of only a 25 Newton force. If the inventor is correct, what is the shortest possible distance through which the force must be applied for each meter that the object is raised? Okay, so guys, let's know that the work done by the applied force, guys, has to be equal to the work done to lift that particular object. And guys, the work done by the applied force now is given as 25 times d, where d now is simply the distance through which the applied force acts through. It therefore implies, guys, that and the work done to lift that object, guys, since since the mass of the object is 30 kilograms, we can get the weight of that object by simply multiplying by the gravitational field strength, and the distance through which that must happen has to be 1 meter squared. It therefore means that the work done by the force, guys, has to be equal to 30 times 10 times 1. Wait, it therefore means that if you simplify, guys, we're going to have an answer to be 300 joules. Okay, now, guys, since the work done by the applied force has to be equal to the work done by the in lifting the object, it therefore means that our WO has to be given as what WA. If we equate both of them, guys, we are going to have 25d to be the same like 300. If we simplify, we're going to have d to be given as 12 meters squared. So friends, option C is the best option. Let's go to the next question, guys. Let's go. Question 42 is saying that which of the following graphs best represents the radioactive decay of this element of 233 mass of uranium. So guys, let's simply recall that this is the only equation that we need. Okay, this is the only equation that we need. We see that the activity normally decreases, guys, as an exponential quantity, right? It decreases exponentially. So which of these graphs is an exponentially decreasing curve? Only option C, right? Great. So option C, guys, is the best option. Okay, question 43 is that the half-life of a substance X is 45 years and it decomposes to substance Y. A sample from a meteorite was taken which contains 1.5% of X and 13.5% of Y by mass. If substance Y is not normally found on a meteorite, what is the approximate age of the meteorite? So guys, if you want to discover so well, you see that the law in which the equation that helped us to be able to identify the graph here is the equation we are going to use here. Now let's reason solemnly, friends, that since substance Y, guys, is not normally found on the meteorite as equation to us, guys, we can therefore lay all our assumptions that all of substance Y, guys, was formed as a result of the radioactive decay of our substance X squared. Now, guys, the initial amount of substance X that is left is related to the final amount by the equation N equal to N0 e raised to the power negative lambda T. Great. Keep in mind that our N in this case, guys, is simply the final mass that is going to be left, and N0 is the initial. Lambda is simply the decay constant, which is simply given as lambda equals the natural log of 2 over T1 half, where T1 half, guys, is the half life. If we take natural logarithm on both sides and simplify and substitute our lambda in place of uh, where we have our lambda in this equation, we are definitely going to have the natural log of N0 over N, which is equal to T in times the natural log of 2 over T1 half. If we make our T the subject in this case, we are going to have 45 over ln 2 into what the natural log of 15 over 1.5. Keep in mind that the final mass that is left is going to be the sum of the 1.5% and the 13.5%. So we are going to have 15 all over the initial, which is 1.5. Then now, guys, our T1 half, which is the half-life, has to be what? 45 years. So everything is in place. Simplifying it, guys, we are going to have an answer to be 149.5 years, which is about 150 years. So guys, the closest answer to this our option, guys, has to be option C. Okay, though it's not the exact answer, but it's the closest. Okay, let's go to the next question. Question 44 reads that in nuclear fission, a uranium nucleus combines with a neutron, becomes unstable, and splits into, we have Ce and Zr plus two neutrons. The change in the mass of the interacting parts is 0.210 atomic mass unit. That this is virtually, guys, the mass defect. How much energy is released in this reaction? Okay, they've given us our C squared to be the same like what, guys? To be the same like 931.5 mega electron volts. That's the C squared. Okay, great. So guys, let's get the questions well, guys. Let's analyze it so well. Let's know for sure that the amount of energy released, guys, is given by the Einstein's famous equation, which is given as E equal to delta mc squared, where delta m, guys, is the mass defect. Great. That means that our mass defect, guys, has simply been given to what, 0.211, guys, and our c squared has been converted to mega electron volt at given to us at once as 931.5 mega electron volts. If we simplify everything, guys, we are going to have each be same like 0.211 into 931.5. Simplifying, guys, we are going to have our answer to be 196.5. We round off the nearest whole number, we are going to have 197 mega electron volts. Great. So option D is the best answer. Question 45 reads that uh, polonium 216 undergoes 2 alpha decays and 2 beta decays to form. Okay, these are the options that they've given us. So guys, only the masses in this case have been given, only their masses. Let's try to decay the polonium, guys. This is it. When it decays, guys, it's going to give us 2 alpha particles, which is a helium nuclide, and 2 beta particles. Keep in mind that we are not interested in their masses, in their atomic numbers. We have to deal only with their mass number. So this is how it's going to decay, guys. It's going to form an extra daughter nucleus here. Let's see, guys. This is 2 times 4 is 8, 8 plus 0. So what we are going to put here, guys, has to be a nuclide which has a mass of 210. So that when you sum up all the individual masses, guys, it's going to give you the mass of the parent nucleus. So option C, guys, has to be the best option. Great. So guys, don't forget to like the video, friends. Give it a thumbs up, guys. Subscribe to this channel if you want to have more great content from us, friends. Question 46 reads that the mass of an atom undergoing a radioactive decay will remain unchanged in all of the following processes except, guys, guys, friends, if you look at it so well, you see that alpha, the right answer here has to be option A, okay? Because the mass, if it emits an alpha particle, the mass is going to increase, the mass number is going to rather decrease by what? 4, okay? Since the alpha particle is a helium nuclide, as you can see here, it's going to increase by a factor of 4. Guys, unfortunately, I sub option D, but the best answer is option E, okay? Please make the correction. Please, guys, it's option E, alpha particle. A beta emission, guys, leaves the mass unchanged, but the atomic number rather increases by 1. For a gamma emission, guys, everything is held the same, both in the mass and in the atomic number. For the electron capture, guys, for the electron capture emission, guys, the same idea applies. Okay. Question 47, guys, simply reads that a helium balloon will rise into the atmosphere until. So, guys, this helium balloon is going to rise until the density of the helium in the balloon, guys, has to be equal to the surrounding density of the atmosphere. So option A is that the temperature of the helium inside the balloon is equal to temperature outside. Guys, we don't talk about the temperature, okay? The temperature in this case does not matter. The mass of the helium inside the balloon is equal to the mass of the air outside it. No, guys, wrong. Option B is not correct. Option C is saying that the weight of the balloon is equal to the force of the upward air current. No, guys. Option D is not the density of the helium in the balloon as equal to the density of the air surrounding the balloon. Option D, guys, is the best option we can take. The best option. Okay, let's go on now, guys. Let's go to question 48. Okay, it reads that Mercury has specific gravity of 13.6. The column of mercury in the barometer below has a height h of 76 centimeters. If a similar barometer were made with water, what would be the approximate height of the column of water? Great. So guys, this question is not so common to the advanced level syllabus. It's not so common, guys, but you just have to learn it so well. So guys, we need to know that if the question told us the specific gravity of mercury is 13.6, it therefore means that the specific gravity of mercury is simply 13.6 as big compared to that of water. So it therefore means that that of water, guys, is 1, that of mercury is 13.6. Great. Okay, now guys, to get the height of water, we just have to take the specific gravity of mercury, multiply by the height in which the mercury column has risen, all over the specific gravity of water. It therefore means that, guys, the specific gravity of water, like I said, is 1, means we are definitely going to have 76 centimeters times 13.6 over 1, which gives us our answer definitely to what, guys, to be 1034 centimeters. So option D, guys, is the best option for this question. Okay, guys, question 49 reads that a child's bottom toy has a density of 0.4 grams per cm cube. What fraction of the toy floats above the water surface? Okay, guys, let's not forget that the density of water, as you all know, guys, is 1.00 grams per cm cube. Now, to get the fraction of water that flows actually, we simply have to take the density of water now minus the density of the child's toy, which is going to be given as 1 minus 0.45, which gives us an answer of 0.55. Now, to get a proportion of the percentage that floats, we have to take 0.55 over the density of water times 100. So if we do that, guys, we are going to have 0.55 over 1 times 100, which gives us our answer to be 55% grade. Question 50, friends, reads that, so option C, friends, is the best option. Question 50 reads that the pressure at the bottom of a cylindrical tube filled with water was measured to be 5,000 Pascal. If the water in the tube were replaced with ethyl alcohol, what would be the new pressure at the bottom of the tube? The density of ethyl alcohol, guys, has been given as that. Let's recall that the pressure is to be given as what, guys? Rho GH. That's the density times the gravitational field strength times the height. If we make our H a subject, guys, because we must have to get the height, we must have to get the height of water. Okay, what must have gotten the height of water? Now we can simply compare it now with that for ethyl alcohol. So if we get the height of the water column, guys, it's going to be, we make H a subject, we are going to have 5,000 over 1,000 times 10. If we simplify, guys, we are going to have our H to be something like 0.5 meters. Now, to get the pressure of the ethyl alcohol, guys, we are definitely going to take from this same formula, which is going to be the pressure 800 Pascal. That's the pressure, which that's density of mercury, which is 0.8 grams per cm cube. If we convert that to kilograms per meters cube, you are going to have 800 multiplied by the gravitational field strength, which is 10. Then now the height of the water column, which is going to be balanced by the height of the ethyl alcohol, so it's 0.5. If we solve that, guys, we are going to have an answer of 4,000 Pascal. So option A is the best answer for this question. Okay, let's look at question 51, friends. It reads that in nuclear fission, oops, guys, I think we've seen this, right? Great, we've seen this already. So guys, let's proceed, guys. So we've seen this part already, right? Question 51, guys, is saying that an ideal fluid with pressure P flows through a horizontal pipe with radius R. If the radius of the pipe is increased by a factor of 2, which of the following most likely gives the new pressure? Okay, so friends, this question is from the concept of fluid dynamics. Fluid dynamics, guys, is simply a concept that is taught in school, okay, in the school in which you are going to enroll in this NAPI examination, in this NAPI school, okay. It's taught at the National Higher Polytechnic School, as well as for those taking the Fed concours, like the one I'm doing the correction now, and other engineering disciplines. Fluid dynamics, fluid mechanics are being taught. Okay, now guys, we simply have to recall so well uh that in such a case, guys, let's see, let's simply know for sure that to get this question done, there are a number of principles that we have to consider. We have to consider the principle of fluid dynamics, guys, and also the continuity equation, as well as the Bernoulli's principle. Great. So now, friends, as for the continuity equation, guys, it simply states that the product of the cross-sectional area, guys, and the velocity of the fluid remains constant. What this law tries to express is that if the initial area is a1 and the initial velocity, guys, is u1, this has to be equal to a2 v2. Now, guys, in this case, now if the radius is doubled, guys, we can say the cross-sectional area increases by a factor of 4, right? As such, guys, we can see that our a1, which is going to be the new area, is now going to be pi. The radius is 2r, which has increased by 2, which the our area a1 now becomes what? Pi r squared, which we can see that our pi r squared is what, guys? Is a, right? So our a1 now becomes 4 times of a. Okay, now, guys, the Bernoulli's principle, guys, is simply saying that for an ideal fluid in a horizontal pipe, guys, the Bernoulli's equation can be summarized as P plus 1 half rho v squared, which is equal to a constant, guys, where our rho in this case, guys, is simply the specific density of the fluid. So, guys, as we saw earlier, that when the radius is doubled, guys, the area increases by a factor of 4, right? So the velocity in this case, guys, also must decrease by a factor of 4 in order to maintain the same flow rate. So, guys, according to Bernoulli's principle now, friends, if the velocity decreases and the pressure in this case, guys, must increase. But in this case, guys, we do not know the exact relationship that exists between the initial and final velocity. Since the velocity has a very direct relationship to do with the pressure, we don't know the initial velocity nor the final velocity, guys, so we cannot draw any conclusion regarding the pressure of the liquid. So, guys, at this point, guys, option D has to be the best option. The new pressure cannot be determined without more information. We need more information such as the initial velocity of the fluid. Great. So, guys, that's it. But if you don't understand, friends, don't bother yourself. Just struggle to get yourself into that concours. You're going to be taught this thing in class. Okay. Let's look at question 52. It reads that all of the following would increase the volume flow rate of a fluid being pumped through a pipe, except, guys, this is from the same concept known as fluid dynamics. But in this case, since the fluid is in motion, it is now fluid mechanics. Great. So, guys, all we have to do in this case is simply to recall that uh, the flow rate according to the Hagen Poiseuille's equation for the flow rate, guys, is simply related to its radius, the change in pressure, the coefficient of viscosity, and the length of the pipe by the equation Q equal to pi r to the power 4 times the change in pressure over 4 times the coefficient of viscosity times L. Guys, keep in mind that in this case, it is solely dependent on what? The radius, right? It's dependent on the radius. Wait, so they said A, increasing the pressure difference between the ends of the pipe. If we increase the pressure difference, guys, the rate of heat flow is going to increase, right? Keep in mind that they want us to get the exception. B, decreasing the fluid viscosity. If we decrease the fluid viscosity, guys, that is this funny end symbol, cure, is rather going to increase since they are inversely related. Now, guys, option C is saying that increasing the pipe radius. If we increase the pipe radius, guys, cure is going to increase. Now, if we increase the length of the pipe, guys, notice that Q and L are inversely related. It is rather going to decrease. So option D, guys, is the best option for this question. Question 53 says that water in a moist soil rises through capillary action. The intermolecular forces between water and molecules are A. Weaker than the intermolecular force between water and the soil. B. Equals to the intermolecular force between water and the soil. C. Stronger than the intermolecular force between water and the soil. D. The intermolecular force cannot be determined with the information given. So guys, we don't seek to calculate the intermolecular force, but we rather seek to determine if it's going to increase or decrease. In this case, guys, option A has to be the best because in this case, the intermolecular forces between the water molecules, guys, have to be weaker than the intermolecular force between water and the soil. If water has to be drawn from the soil up by capillary action. Okay, great. So guys, option A has to be the best option. Option A has to be the best one. These are the explanation, guys. These are the explanations. So just go through them. You say your answer is going to be option A. Okay. Let's go to question 54, friends. Are you ready, friends? Let's go. Question 54 reads that the Young's modulus for bone is 9 times 10 is 9 times 10 raised to the power the sum value here, friends. Just that the question itself made an error by not giving the value. Okay, but after further investigations, guys, I saw that this value here was 9. Okay, it was 9. Wait, that's 10 raised to the power 9. What is the percentage change in length of a tibia with a cross-sectional area of 6 centimeters squared if it experiences a compressive force of 4.5 times 10? Guys, this also has to be 10 raised to the power 3. Okay, wait. Okay, so friends, in such a case, let's simply recall that the Young's modulus is simply given as the ratio of stress over strain. In this case, guys, we make the strain the subject. The strain is simply given as the stress over the Young's modulus E. Now, the strain in this case has been given as this. The stress has been given, guys. We can get the strain right. Wait. So the stress in this case, as you all know, guys, is simply given as the force over the area, then divided by the Young's modulus, uh which has been given. So if we plug in everything, guys, we are going to have our strain to be the same like 5.4 times 10 raised to the power 3 over 6 times 10 raised to the power negative 4 into 9 times 10 raised to the power 9. Keep in mind that we have to convert the area from centimeters squared to meters squared. So simplifying, guys, give us our answer to be 0.01. Now, guys, therefore means that if we our strain energy now, the percentage change in strain has to be given as uh the strain energy itself is simply given as the change in length over the original length. Okay, that is how the strain is given as the change in length over the original length. If you're talking about the diameter, it's the change in diameter over the original diameter, but in this case we are dealing with length, so it has to be a change in length over the original length. So the percentage change now has to be given as just taking this result and multiplying by 100, which obviously gives us answer to be 1%. So option C is the best answer. Okay. Question 55 reads that the bulk modulus of a substance will be most important to a researcher who is testing materials that will. So guys, the bulk modulus now simply talks about materials that are being subjected under very, very high forces, okay, under very, very high tensions. So let's recall that, okay. Option A is saying that used in high tension cables, guys. No, they are not being subjected to very high forces. B is submerged deep in the ocean. Perfect, guys. Perfect. This has to be the best option. Option C is not subjected to high temperatures. No. D, transported at great speeds. No, guys. Option B, guys, has to be the best option for this question. So, guys, these are the explanations. As you can see, these are the explanations that the bulk modulus is a measure of a material's resistance to uniform compression. It is particularly relevant in environments where the material is subjected to very high pressure at all sites, guys. So, option B has to be good. Great. So, guys, question 56 reads that Which of the following gives the percentage change in the Young's modulus for a substance when its cross-sectional area is increased by a factor of 3? Okay, guys, let's recall that from the Young's modulus, which we just saw, it's me given as the stress over the strain. The stress is given as the force over the area. The strain remains the strain. It therefore means that, guys, if we make our E therefore becomes, let's symbolize this our strain to be given as capital S, right? So this is now our Young's modulus. Now in this case, now when the cross-sectional area is increased by a factor of 3, now the new Young's modulus, which can call that E1, is to be given as F over 3 AS, right? Which can write that as E1 equal to 1/3 of, since F over AS is what our E, right? So we are going to have E1 being equal to 1/3 of E. And if we take this 1/3 and divide by 100, guys, we are going to have answer to be to the nearest whole number to be 33%. So option B is the best option for this question. Okay. Question 57, guys. Let's go. It reads that waves generally travel faster in solids than in gases because, okay, these are the various options. So guys, let's try to analyze it very keenly. A is that the density of solid is generally greater than the density of a gas. So guys, this is not obviously true, guys. While it is true for that of solid, guys generally have very high densities, guys. Okay, they have very high densities than gases. Solids normally, guys, have high densities than gases, and as such, guys, the density alone, guys, is not a sufficient factor that determines the speed of propagation of the wave. Okay, great. It does not determine it independently. The density itself does not determine it solemnly. Now, option B, guys, is saying that the density of gases is generally greater than the density of solids. Like I said, guys, the density has no role to play in this case. Okay, the key factor is how easily the medium can be compressed. Okay, not the density. The density has no role to play virtually in this case. So guys, I think the best option here has to be option C. Okay, that solids are less compressible than gases. So guys, option C has to be the best option. Solids are less compressible than gases. Great. Okay. Question 58, friends, is saying that, so friends, along the line, if you don't agree with me with any answer, friends, please let me know in the comment section down below. Okay, if you don't agree, let me know, guys, and we shall see what to do. Question 58 is saying that sound waves are example of a longitudinal waves. That is true because the medium moves perpendicular to the propagation wave. Wrong, guys, wrong. B, longitudinal waves. That's good because the medium moves parallel to the propagation of the wave. Perfect, guys, perfect. Option B is the best. Option C and D are talking about transverse waves, which are wrong. Transverse wave, guys, are for light waves. So option B, guys, is the best option for this question. Question 59 says that if the guitar string is 0.5 meters long, what is the wavelength of its third harmonic? Friend, let's simply recall that the wavelength of its third, keep in mind that the guitar string in this case is fixed at both ends. Okay, it is fixed at both ends, and so the wavelength of its end harmonic, guys, is to be given as lambda n equal to 2l over n. Its third harmonic means that our n becomes 3, which we are going to have our, since our L, the length is given as 0.5, we're going to have 2 into 0.5. Our N is 3, since we're talking about the N, the third harmonic, we are going to have 3. Simplifying this result, guys, give us one answer to be 0.33 meters. So option B is the best option. Let's go to question 60, guys. Let's go. It reads that when two waves are superimposed, the resulting wave can be found by summing their A frequencies, B period, C wavelength, D displacement. The best answer here, guys, is displacement. Great. This is simply based on the principle of superpositioning of waves. Okay, the resultant waveform now is going to be formed by the sum of the vector sum of their individual displacement. Great. So guys, I think that's a direct question. Then friends, the question 61 is saying that a vibrating string has consecutive harmonics at wavelengths 2.0 meters, and that what is the length of the string? Okay, so friends, since they're talking about a vibrating string, it therefore means that, guys, and the wavelengths, as you all see, right, are whole number multiples, right, are whole number multiples. So this is simply a case wherefore it is fixed at both ends, and as such, guys, the wavelength of its nth harmonic, like we saw initially, is to be given as lambda n equal to 2l over n. Now, guys, this has to be equal to, guys, this has to be equal to the first uh harmonic wavelength, which is equal to 2. So we are going to have lambda n to be the same like 2l over n. If we use the left side portion, guys, we cancel the 2 on both sides. We're going to have our L to be the same like n. Let's call that equation 1. Then, friends, it therefore means that our lambda n plus 1 now has to be equal to, when our n becomes n plus 1, we are going to have 2L over n plus 1, which has to be equal to the consecutive, which is going to be 4. It therefore means that, friends, at this point now, we are definitely going to, if we solve for our n so well, guys, we are going to have our L minus 2 equal to 2n. But what is n, friends? Our n is what? Our L is what, guys? N, right? So we are going to have n this way. If we simplify, guys, we're going to have our L to be the same like negative 2. But we seek to get the length, right? Not some value. So we have to get the absolute value of the length, which has to be positive 2. So option B, guys, has to be the best option for this question. Okay. Now, guys, let's look at question 62. But friends, keep in mind that we didn't just plug in n equal to 1, n equal to 2, and so on, guys. We try to use the general way in which they are defined in such a case. Okay. Question 62, guys, simply reads that in order for two sound waves to have an audible beat frequency, the two waves must be A in phase. Wrong, guys. B out of phase. Not correct. C close in frequency. Great. Option C is the best option, guys. Okay, it's the best option because to have an audible frequency, guys, the two sound waves must be very, very close in frequency. If the two of them must interfere to produce a much audible frequency, they must be of very, very close frequency. So, guys, option C is the best option. Question 63 simply reads that if the mass of a bulb, if the mass on the bulb of a pendulum is increased by a factor of 3, the period of the pendulum motion will. These are the options. So, guys, let's recall that the period of a pendulum, guys, is simply defined by the formula T equal to 2 pi square root of L over G. In this case, we can see that the period T is independent of the mass of the bulb, right? It's highly independent. So the mass has nothing to do with the period of the bulb. As such, guys, the period, guys, will remain the same. So option B, guys, is the best option. Okay, guys, let's go to the next question. Let's go to the next talking about. Okay, this is where we are, friends. uh this is where we are. Okay, this is the question. Okay, that has been done. Okay, now, guys, let's try to recall how that graph looks like. Okay, let's try to recall how the graph looks like. This is how the graph looks like. This is how the acceleration due to gravity varies with increasing distance from the from the center of the earth up to the earth's surface. It varies directly. Okay, it's directly proportional to the radius, but at some distance above the earth's surface, guys, it varies as an inverse square relationship. Okay, it varies as an inverse square relationship. This is under gravitation, friends. So if we use our formula T equal to 2 pi square root of L over G, where this our L now becomes our R, it therefore means that when we move above the Earth's surface, G rather decreases, right? It decreases very, very fast. That is, it obeys an inverse square law, okay? It obeys an inverse square law with respect to the radius. So in this case, guys, when this our G decreases, we expect our T to increase, right? Therefore means that option A, faster than it would on the surface of the earth, guys, that is the best option. Okay, option B, saying that slower, no. Option C, at the same speed, no. Option D, at the same speed, no, guys. So option A has to be the best, faster than it would on the surface of the earth. Great. Let's go to the next option, guys. Let's go. Question 6-7, guys, is saying that all of the following are examples of harmonic motions except a pendulum bob, a pendulum moving back and forth. That is an example. B, a skydiver falling through the atmosphere. Wrong, guys. B is the only exception. Okay, is the only exception. Then a car traveling around through a circular track. That can be taken. Then, friends, option D, uh, a string vibrating on a musical instrument. Guys, this is correct. So option C, guys, is perfect. Since the car travels around, it passes, it comes to its equilibrium position always and always. Okay, so it is, the motion is can be taken as harmonic motion. Question 6-8 is saying that the electric field for 2 point charges A and B as shown below. Which of the following is true? A, both charges are positive. Guys, this is the only best option we can take. Even without looking at the rest, guys, option A is the best. Okay, option B is that both charges are negative. Wrong. If they were negative, like the fields would have been entering the charges, not leaving, as the arrow suggested here. Okay, but for positive charges, guys, the electric fields are leaving, the positive charges are entering the negative, so they must be positive. Then C, the charges have opposite, charges. Not enough. Okay, option D, the charges cannot be determined. They cannot be determined. Yes, but they are both positive. Wait, so option A is the best. um Friends, question 69, friends, is simply saying that if the distance between a point charge the distance between a point charge and an infinitely large charged plate is increased by a factor of 2, the new force on the point charge will, these are the options. So for instance, let's simply recall that for an infinitely large charged plate, the electric field E is simply given as our E being equal to sigma over 2 epsilon 0, guys, where epsilon 0, guys, and sigma are the permeability of free space and the surface charge density. Great. That therefore implies, guys, at this point now, we know that the force F on a point charge Q in this electric field, guys, can be given as F equal to Q E, where this is the electric field created by this infinitely large plate. It therefore means that, guys, if we substitute our E into this our formula, we are going to have our F being equal to our Q. Our E is what? Sigma over 2 epsilon 0. So we have this. We can see that, friends, what that this our force now, friends, is independent of what? Of the is independent of the distance, right? Independent of the distance. So in this case, guys, option C has to be the best, that it will remain unchanged. Okay, option C is the best, it remains unchanged since it does not depend on the distance. Great. Okay, let's go to the next question, guys. Question 70. Let's go. It reads that each resistor in the circuit below has a resistance of 22 ohms. The battery is 12 volts battery. What is the current across the resistor B? Okay, guys, this is a question that is based on current electricity, guys. Let's start by guessing the combined resistance of this entire network. Let's keep in mind that resistor A and resistor B are in parallel, and the whole combination is in series with resistor C. So we are definitely going to have the resistance of B, A, and C being equal to 22 times 22 over their sum plus now 22. This simplifies to what, guys? 33 ohms. Now we need to get the current that will be flowing throughout this circuit, which we can get it from Ohm's law, which is saying that I is equal to V by RT. That means that, guys, our I becomes, our V is 12, our R is 33. Simplifying give us an answer to be 0.364 amperes. Now, guys, since resistor A and B now are in parallel and are equal, therefore means that what the current that is going to be flowing here, guys, will be shared equally among resistor A and B since they are in parallel and they have the same resistances. So it therefore means that it's going to be shared in the ratio 1:1, means we are therefore going to have our IB, which is going to be the current flowing through resistor B, to be same like what, guys? To be same like 0.364 divided by 2, which gives us another to be 0.18 amperes. Unfortunately, guys, none of these answers are corresponding. So maybe there was an error with this question, guys. I don't know. Maybe there was an error. Okay, let's go on, guys. Question 71 reads that what is the energy required to operate a 60-watt light bulb for 1 minute? So, guys, it's very direct. Let's know that our energy E, guys, is simply given as power times the time. That's the power times the time interval in which the bulb is being used. So we are therefore going to have our E based like the power is 60 watt and the time is 1 minute. We have to convert 1 minute to seconds. So we are going to have 6 times 60, which gives us 303,600 joules squared. So option D is the best option, guys. The best option. Okay. Question 72 reads that which of the following changes to a parallel capacitor would not increase its capacitance? A. Decreasing the distance between the plate. Okay, so guys, let's recall that the capacitance is related to its dielectric area and the distance by the formula uh, C equals epsilon 0 A over D. Let's recall that option A is not decreasing the distance between the plate. That is, if we decrease D, it's going to increase C, right? But we want that case where it will not increase, so option A is not good. Option B, increasing the area, it will increase the capacitor since they are directly proportional. Then option C, increasing the dielectric constant, it will increase it since they are proportional. Option D, increasing the voltage across the plate. Keep in mind that they're talking about parallel plate capacitors in this case, okay? So option D will not do it. I know there are so many of you that will be talking to me that how about the formula Q equal to CV? This is for a case where for a potential difference is being applied across the plates of a capacitor, but an ideal capacitor in such a case, guys, does not depend on the voltage. It depends on these quantities I've listed here. Great. So, guys, option D has to be the best option for this question. Okay, let's go on. Question 73 reads that all of the following expressions are equal to the ohm except. Okay, so guys, let's recall solemnly that the ohm can be given from Ohm's law by the formula R equal to V over I, where V is the potential difference or the voltage, I is the current. It therefore means that, guys, we also know for sure that what our Q from the fundamental concept of electrostatics, Q is equal to IT, where T is the time taken. It therefore means that, guys, our I becomes what? Q over T, right? As such, if we substitute back into where we have R, guys, we are going to have R to be same like Vt over Q. The unit of voltage, guys, is the volts, and the unit of time is the second. Unit of Q is the coulomb. So we are going to have V second over coulomb. So option A is among. Let's look at option B, friends. We simply have to recall that our power P is given as I squared R. If we make R the subject and stick by its units, we are going to have R to be something like P over I squared. Unit of P is a watt, I squared is in amperes squared, so we have R to be something like W over A squared. So option B is good. Then, friends, let's keep going. We also know that what, guys, our P, that's the power, can be given as what, guys, the square of the voltage over the resistance. The voltage is in volts. It therefore means that, guys, we make resistance the subject. We are going to have R to be the same like V squared over P. Unit of V, that's the voltage, is the volts, that's V squared over the unit of power, as we all know, is the watt, so we have V squared W. So, guys, the only exception to the answer here is what? Option C. So option C, guys, is the only that is not among. Wait. So, guys, that's it. Let's look at question 73, guys. It reads that if an AC current delivers to a home by an electric company is delivered 1000, that's 120 VRS, that is the root mean square voltage. What is the maximum voltage across the outlet? So guys, let's recall that the maximum voltage, that is V max, is rather given as the root mean square voltage times the square root of 2. If we simplify guys, the root mean square voltage is given as 120. Multiplying it with root 2 guys give us our answer to be 169.7. Bringing it to the nearest whole number, we have it to be 170 volts. Great. So option C is the best option. Question 75 friends reads that the magnetic field created by a long straight current carrying wire A decreases in strength proportional to the distance that, okay guys, let's analyze them so keenly. Let's analyze them. Let's recall that the magnetic field strength created by a long straight current carrying wire guys is simply related to the permeability of free space and the current that flows through it and its separation r by the formula B equal to mu 0 I over 2 pi r. Okay, now we notice that B in this case is inversely proportional to what? R, right? Great. It's inversely proportional to R. In this case, guys, where our B is the magnetic field strength, our mu 0 is the permeability of free space, I is the current, and R is the distance from the wire. Great. That therefore implies, guys, option A is saying that decreases the strength proportional with the distance of the wire. That is when the strength decreases when the distance increases. Is that it? Does that make sense, friends? What do you think? Great, guys. Option A has to be the best, even without looking at the rest. But let's look at the rest, friends. Option B is in that decreases in strength with the square of the distance. Wrong, guys. It is proportional and not proportional to the square of the distance. C increases in strength proportional with the distance of the wire. No, guys, it is inversely related. Increases the strength with the square of the distance. Wrong, guys, wrong. So option A is the best option. Okay, let's go on, guys. Question 76 is saying that a charged particle moves horizontally through a magnetic field with points directed outwards. The force on the particle due to the magnetic field is. So guys, when I read these questions well, what exactly should come to our mind is simply the Lorentz force. Okay, how to get the Lorentz force since a charged particle is moving in a magnetic field. So there's going to be some force that is going to act on that particle which move horizontally in the magnetic field, and it is given by the Lorentz force. So guys, the force in equation, like I said, is simply the Lorentz force, and the direction of the force on the charged particle, guys, moving the magnetic field can be determined by the right hand rule, which simply wants you to align all your right hands in such a way that they are all at right angles to each other. Such that, guys, if you do that so well, guys, you see that if all the hands are aligned at right angles, guys, you will see that what that the direction of the force is going to be perpendicular to both the magnetic field and perpendicular to the velocity of the particle. So option D, guys, has to be the best option, and it is a feature of the Lorentz force. Okay, it's a feature. It is always perpendicular to both the magnetic field direction and the velocity of that particle, guys. That's it. Question 77 reads that a particle of mass m is fired into a magnetic field of strength B at a speed v. The particle travels in a circular path inside the field with a radius a, with a radius r. Which of the following expression gives the magnitude of the charge on the particle? So guys, in such a case, we have to recall that the trajectory of a particle that moves, or for a charged particle that moves in a magnetic field, is simply a circle, right? That's the trajectory. And what provides the centripetal force is simply what? The magnetic force. Guys, if you don't know about this concept, you cannot pass this particular question. It therefore means that what the centripetal force is given as mv squared over r, which is equal to the magnetic force is simply given as B cure B. Keep in mind that we have to get the value of cure. If we make cure the subject, guys, you're going to have cure to be something like mv over b r. So option B, guys, is the best option for this question. Let's go to question 78, friends. It reads that which of the following graph best represents a particle with constant velocity? So guys, this is the question where I want you guys to listen out with me to reason it out with me, friends, and tell me what you think about this question, okay? I would like to get your own opinion, friends, about this particular question. I really want to get your opinion, friends, because according to my own reasoning, guys, I did not see any of the answers correct because we aim at getting the graph whose velocity is constant, right? Let's look at it first. In this case, we have a displacement time graph in which the graph is not a straight line. The graph rather changes. So, and we know that the slope of a displacement time graph tells us what, guys? Tells us the velocity, right? If we try to take the slope at every point on this graph, we see that what, guys? The slope will not be the same, right? The slope will not be the same. Yeah, the slope will not be the same, guys. So as such, the velocity in this case will not be constant. If you look at the second, guys, the displacement in this case is constant. So velocity in this case cannot be constant. It will be zero. It will be zero, guys. The velocity will be zero. That's zero. Okay. If you look at the acceleration, guys, acceleration is what? Uh, Constant in this case. Constant, but not zero. Okay, so it is not constant. Velocity is not constant. Then, friends, then option D, guys, this is an acceleration time graph which increases, which the velocity, obviously, if the acceleration is not constant, guys, the velocity cannot be constant. So, guys, please let me know in the comment section down below, guys, what you think about this particular question. It's very, very important, okay? It's very, very important. Let's bring our heads together, guys. Tell me what you think about this question. Okay. Now, guys, let's look at question 79. It's saying that compared to human bees, compared to humans, bees perceive a slightly higher frequency of electromagnetic waves. Based on only these informations, to which of the following flowers color is a bee most likely to be attracted, more likely to be attracted to? So, guys, bees are rather going to be attracted to that color which reflects electromagnetic radiations. And in that spectrum, guys, we know that the two colors are what, guys, are simply blue and violet. Okay, blue and violet. So option D has to be the best option. Question 8 is saying that which of the following is not a possible path of a light ray through a glass lens? Let's look at the first option, guys. The light moves like this, bends like this. It is a possible way. Option B, guys, when the light ray moves straight to the lens, it goes without bending. Perfect. Option C, guys, is the only exception, okay? Because this is a concave lens, wherefore a ray of light that is parallel to the principal axis, guys, after reflection should appear to be coming from the focus, okay? It has to appear to be coming from the focus like this and not bending like how it's for this convex lens, okay? So, guys, option C has to be the only answer, okay? That's be the only answer, which is the only exception. In this case, it is normal, okay? It is perfect in this case. So, guys, thank you for watching the video, guys. Thank you. I wish you all the best as you prepare for your exam, guys. Like I said, guys, I'm pretty much sorry that this solution is coming very, very late, okay? I had some difficulty with my machine, and still now, guys, I still have the same problem, and I'm trying to fix it. Thank you very much, guys, and good luck as you prepare for your exam. Have a blessed day.